Hello everyone, my name is Shaban Mchomvu and I'm going to present the concept of integration. Welcome. Today we are going to see the integration concept. Introduction, we'll see the definition of integration. Integration is the reverse process of differentiation. It means if you want to know how to integrate, it means you need to have the concept or the idea of differentiation. Suppose we have the differentiated function. We have dy dx. That means the differentiation of the function with respect to independent variable x, which equals to a certain function. Now, for we to obtain this value of y here, we need to integrate this function now with respect to the independent variable x. And then now what is this function? This function here, it is what we call it the integrand. And normally, when we integrate it, we need to consider the variable of respect, which is x. If it is not the variable of respect, it means that will be the integration of a constant. So by so doing, to obtain y, as I said earlier, that we need to integrate. And how do we integrate now? For example, here we have dy dx equals to the function of x. So what are we supposed to do here? It means now we separate. We apply variable separation like this dx, because it contains the variable of respect. It has to follow the function that has the variable of x. So what we do is like saying dy equals to the function of x, then dx, the math of just multiplying there. From there now, we apply integration both sides. And the integral sign, it is given by this one. So this is integral sign. Integral of dy equals to integral of the function of x, now with respect to x, is what now we have in the notation here. Y equals to integral of f of x with respect to x. So when you integrate this dy, it means here we'll have y equals to here the integral of f of x with respect to x. So how do we obtain this y here? We'll see in the techniques of integration. Is what we call the power rule of integrations. So from there, so we say now, the technique is now of integration. Technique number one is what we call it, or goes by the name power rule of integration, which is expressed as integral of the power function with respect to x is less more to, it is x n plus 1 over n plus 1. Now we plot the constant c, where now here to the denominator, we don't want here to become 0. So what we do, we say this n here, if you don't want to become 0, n plus 1 we say is not supposed to be 0. So when you are looking for the value of n, it means n is not equal to negative 1. So we say n not equal to negative 1. Because when it becomes to negative 1, it means here we'll have 0. So number over 0 we know is undefined, does not exist. So for the rule now to exist, n is not supposed to be negative 1. And this is what we call it the power rule of integration, whereby this x raised to n, this is the integrand. This is what we call it the integrand. That the function needs to be integrated. And with respect to x, it means whatever we are integrating, if it does not contain x, it is constant. That we say its integration value will be 0. Now let's see how do we integrate the power functions. So we recall our power rule, that is integration of x raised to n with respect to x equals to xn plus 1 over n plus 1. Now we plot the constant c where n not equals to -1. Yes. Now from here, we can say also integration means the sum. That's the power, we add the power by 1. But when we differentiate, we reduce the power by 1 also. So for example, on how to use the power rule. Number 1, integrate. We are going to integrate the integrand, that is x cubic, with respect to x. So here, we are going to apply the power rule of differentiation, and we have our integrand, that is x cubic. And now it's simple now, solution. So we recall the concept that integration of x raised to n with respect to x equals to xn plus 1 over n plus 1, provided n not equals to -1. All right, we plus constant c where n not equals to -1. We introduce this arbitrary constant because we integrate without the limits. But if we'll reach to the point of types of integrations where we have the limits, this constant c is not going to be applicable. We are going to get just the constant value. So we just introduce here because we don't know exactly the constant. That's why we say the constant is there, and we don't have the limits. So when we now integrate x raised to 3 with respect to x equals to xc, now our n here is 3. So where n, you just insert 3. So it will be 3 plus 1 over 3 plus 1. Now we plus the constant c. So you will get now x raised to 4 over 4, then we plus the constant c. So this now mark how we integrated now the integrand x cubic with respect to x. So we end up on getting x raised to 4 over 4, we plus the constant c. So from there, we can also see part b. Maybe now we integrate. Now we change. Maybe it's the root of x now with respect to x. So we can still use the power rule of integration. And now the notation here, it involves radical. That's the radical of x. So we can express this radical form into the form where we can see the base and the exponent. So it's like saying the root of x is the same as saying expressing it in exponential form. So we transform from the radical form into exponential form. So that's it's less more to say xc, because the index here is 2. Now it becomes x raised to 1 over 2. Now from there, our n now we can see n is what? A half. And the base now is x. So now it looks like the power function. So what to do? We are going to insert it directly. That this one is the same as saying the transformation for the radical of x becomes x raised to a half with respect to x. Then from here, we can apply the power rule so as you can integrate this integrand x raised to a half. So it will be now xc, then that a half we plus 1 over that a half plus 1 Then now we plus constant c. Why? Because we don't have the limit. We need to introduce the arbitrary constant. Then from there, this becomes xc. This one is a half plus 1 is 1.5, then is the same as 3 over 2. The same as 3 over 2. Then here we have also 3 over 2. So on simplifying, it becomes 2xc, then 3 over 2 over 3. Or you can just simplify more, and it becomes like, we express this in radical. So it becomes 2 radical, then x here, 3, then over 3 here. Or further simplification, we can just simplify here inside, and it becomes 2xc, then the root of xc over 3. So now the value of this one now becomes the root of x with respect to x. Now it becomes, it is 2x over 3, the root of xc. Now we plus c, the constant c. Yes. Now let's see also for the other kind of power function of different form. What if we have two functions or two powers where we apply the operator either plus or minus? Let's see how it becomes. Maybe C, we integrate maybe x, 1 minus 3x, now with respect to x. So here you can see the power functions and the expression, but within the expression there are terms that are powers. So how do we integrate with the concept of the power rule or technique of integration? Solution, what we need to do here, it means we can open the bracket so as we can have the general expressions. So let's see the other kind of example where we have the power function but involving operators like minus operator. So having the problem like this, for we to integrate, we need to simplify first by multiplying with this x here outside, so as you can have powers where they are separated by the operator either plus or minus. So what to do? Now we can say xc 1 minus 3x. This is less more to say. You open the bracket, so it becomes x, this time that, minus 3x squared. So now we can see powers separated by minus operator. From there now, when we introduce integral, that is x minus 3x squared dx equals to, so at this point here now, you can integrate separately every power, and they can be separated by the minus operator. So we say it's just the integration of x with respect to x, then minus integration of 3x squared with respect to x. You just take the integral sign inside the terms together with the letter of respect. Then from there, integrating now x with respect to x, here remember the power here is 1. So we can just go to the power rule of integration. So if the power is 1, it means our n is 1. So now this becomes x 1 plus 1 over 1 plus 1. Now we plus constant 1 because we've just integrated at this part. Then now we proceed minus here when integrating, because integrating involving sum. So this constant 3, we just take it out of integration because formally the integral sign was the same as sigma notation. So it concern with sum. So if here is 3, it means 3 here, I have to take it out. So it's the same as saying 3 integral of x squared with respect to x. Anything that does not concern with the letter of respect, it has to be taken out. So from there, Here we'll have x squared over 2, we plus constant 1, minus, here we'll have 3, but integral of this now becomes 2 plus 1 over 2 plus 1. Then now we plus another constant because here we're integrating for the second time. So from there, this C1 and C2, that's are the constant, and we don't know the value of this constant. So we can say C1 plus C2 is the same as C. So this now becomes x squared over 2. So we minus here, it's become 3x cubic over 3. Now we plus. C1 plus C2 is just constant. So we just express it as constant. So here we'll have x squared over 2. We minus, we can simplify here, this cancel out. So we remain with x cubic. Now we plus c, the constant c. So therefore, the value of the integral xc, then 1. Now this now becomes the value of the integrand, xc, then 1 minus 3x bracket t with respect to x. And from here, this marks the end of the power rule of integration, as we have studied and we have solved the examples. For more concepts, keep watching our video. Thank you very much.